start with something called angle of friction. So what we have got an inclined plane where we have got some arrangement so that we can change the angle theta or we can increase the angle theta right from 0. And for any angle theta, if I have a block kept on this inclined plane, which is rough, it will be having component of mg acting down the inclined plane, which is mg sine theta. Is going to have mg cos theta normal contact force. And since this block will have a tendency to slip down, so the friction force that is going to act on it will be acting upward. Now, what we'll do, if I'll keep on increasing that angle, we'll find at a certain angle when we are going to see the slipping to start. Okay, now. So at the verge of slipping, what we can say, the friction force, whatever will be acting, will be maximum. And then in that case, the maximum friction force is going to be equal to mg sine theta. And we know that the maximum friction force that it can be is mu times normal contact force. And what we can do, we can check out normal contact force is going to be mg cos theta. So we have mu n to be equal to mg sine theta. And this is our mg cos theta. So it is going to be, so what we get is, simplifying it, is tan theta equals to mu. And this angle theta is called angle of friction. I hope everyone got it now. Quite simple thing only. Those who have came late, just I'll repeat for them. We've got a block kept on an inclined plane, and we have got an arrangement by which I can increase the inclination or I can change the angle theta. So what we'll do, we'll keep on increasing this angle theta very slowly right from 0, and we'll see a moment when this block will be just about to, just when it is going to slip, or just when it is going to start to slip. At that moment, the friction force, whatever it will be, is going to be the limiting friction, and we know it is mu times normal contact force, and it is going to be equal to mg sine theta because it is at the verge of slipping. So mu mg cos theta equals to mg sine theta. We got tan theta to be equal to mu. That theta that it is here, it is called angle of friction. Okay. So copy this thing, everyone. After copying, tell me.
Copy it, sir.
Tell me, which is easier? It is easier to pull a object, or is it easier to push a object?
Pull the object, sir.
Why?
Sir, from up, sir, you are asking from up on the inclined plane or
No,
down on the inclined plane,
no,
sir.
not like that. On horizontal surface only. I'll take a new page. Okay. I have created a poll also. I hope you can see that. I don't know. First time I'm trying it. Suppose if you given an option that we are supposed to move an object on a rough surface by pulling it, one choice it is given to us, another choice is given to us by pushing it. In which case it is going to be more easier, whether it is going to be easier to push an object or it is going to be easier to pull an object. Any
Pushing is
idea?
easy than pulling, sir.
Why?
Sir, pushing it will be easy for us to push than the force which acts towards us, sir.
Okay. I want some proper logic to support that, not like just because you like pushing maybe your body maybe like that easier to push. That is not the reason. I'm talking in
Sir, work
terms
done
of
will be different, sir,
yes, tell
in
me.
both the cases. Work done will be different in both the cases.
Work done. I will not talk about in terms of work done because we have not reached to that particular point in syllabus. Still, we have not started work for energy.
Sir, because when we push it, the theta is the when
No,
we
no, no. Think in terms of
Sir, pulling
think
will
in
be easier, sir.
pulling will be easier. Think in terms of in which case friction will be more or less. And obviously, will not be pulling or pushing this block by lying on the surface. No, we can't apply a force parallel to the surface, or we can't pull it parallel to the surface, since we will not be sleeping on the floor and then we'll be pulling it. No, is it not? And standing, if I'm pulling or pushing something, I'll end up pulling or pushing at some angle only, no, with horizontal. So what you will find is that in one case, suppose this first case, if I'll take, suppose if I'm pulling this object at an angle theta with a force F, and I have to compare the pushing case, so I'll also consider we are going to push a same object, same surface in the same angle made with the horizontal in this way. Now, first we'll discuss the case of pushing. Okay, just a moment. Now, what I will do, I'll take the components of this forces, force F. So I'll have F cos theta this way, and then we are going to have F sin theta. Apart from this, we are also going to have the normal contact force mg acting down, and since friction, it is going to have a tendency to slip forward, the friction force on the block I'm talking will come backward. No? Now, we are not applying that much force that we are making this block to lose contact with the surface. Okay, getting the point. So we are just applying force so that we are able to make this block to slide on the surface without lifting it from the surface. Okay. So what you see is the force that is really making this object to move on the horizontal ground is this force F cos theta, which is the component of F along horizontal. So for the block to be able to be moving, for us to be able to move that block on the surface, F cos theta must be more than the maximum the friction can act, or at least equal to. And since this block has got nothing happening in the vertical direction, so net force in that direction should be 0. So what we have is F sin theta upward, normal contact force also upward, mg acting down. So what we get here is n is going to be mg minus F sin theta. Now you see, if I apply a force, so what I have, suppose if I'll talk about when the normal contact force will become 0. Normal contact force, if I'll equate to 0, we have mg must be equal to F sin theta. So F is going to be equal to mg by sin theta. So here we are not applying a force which is bigger than this. Or even I'll say we are applying a force which is lower than this. So that this block must not be losing contact with the surface. So in case if you find normal contact force and in case you get it to be negative or 0, it means the block has lost contact with the surface. So anywhere in any case, if normal contact force comes negative or 0, it means the block or whatever objects are involved don't have any contact present between them. Okay. So here we are just applying force so that this block must not lose contact but should be able to slip on the surface. So now what I have is normal contact force to be equal to mg sin theta. So what you see, because of the way we are applying the force F, the normal contact force which was supposed to be mg in the absence of this force, now it is lower than mg or not. So we are basically reducing normal contact force by applying a force like this. Correct. So that is the reason the friction force that will come into picture will also, or the maximum friction force that will come into picture will get reduced. No, correct. So now F cos theta is supposed to be more than or equal to mg. More than or equal to F max, which is going to be mu times normal contact force, which is basically mg minus F sin theta. So F cos theta minus of mu plus of mu F sin theta must be more than or equal to mu mg on simplifying will get. So F should be more than or equal to mu mg by cos theta plus mu sin theta, no? So the minimum force that we can apply to for a given angle, I'm talking about, the minimum force that we must apply for a given angle is mu mg by cos theta plus mu sin theta. Correct? So this is the case when we are trying to pull an object instead to push an object, no? Those who came late, do you want me to repeat this thing or it is familiar to you? Maybe you might be knowing this thing from before also.
Can you repeat it once again?
Yeah, I'll repeat, no problem. See, I asked which is better or which is more easier to do to drag an object on a surface. Is it easier to push an object or is it easier to pull an object? So what we are going to do, if I take the case, I'm going to pull an object with a force F at an angle theta from horizontal, or I am going to push an object with same force F at an angle theta from horizontal as shown here. And why this angle will come, because we are not going to be pulling or pushing by lying ourselves on surface, no, like this. You can see that, no? So whenever we are standing and then trying to pull like some luggage or something, we will end up pulling at some angle or we'll end up pushing at some angle only. So what we have is, so first we are going to check the case when we are pulling an object. So here we are pulling this object in a manner such that this object must not be losing contact with the surface. So the normal contact force will not become zero. Okay. And this object is not going to have any motion happening in the vertical direction. I took components of our forces. So what we have F sine theta and normal contact force in upward direction. So F sine theta plus n must be equal to mg. So normal contact force became equal to mg minus F sine theta. Now suppose if this force F was absent, the normal contact force that is going to be here will be mg only. So because of the way we apply this force, this normal contact force is reduced. So the maximum friction force will get reduced, no? Correct? So and the force that is really making this object to move is F cos theta. So you see that one of the component of force F sine theta is reducing the normal contact force. And the other component is the one which is acting against friction so that the block can be dragged on the rough surface. And for this block to be able to slip, F cos theta should be more than or equal to F max. F max will be mu times normal contact force. Solving it, we got F must be more than or equal to this. So for a given angle theta, I am talking about for a given angle theta, the minimum that I must apply is when it is equal to this, which is mu mg by cos theta plus mu sin theta. All of you understood now?
Yes, sir.
Okay. Now suppose even further if you want to go, like, okay, angle theta can be also changed. Okay. Then what is the minimum force I can apply? So what do you see? This minimum force that is to be applied is a function of theta or not? Correct? So I can apply maximum minima, but we don't have to, because I told you a cos theta plus b sin theta form. What is the maximum value it has? Root over a square plus b square, no? And you see, this f minimum is a function whose numerator is constant. Denominator contains the term containing theta. So for this force to be minimum, or for this entire expression to get minimum, the denominator must become maximum for some angle theta. So the cos theta plus mu sin theta, the maximum it can become is 1 plus mu square root over, no? Correct. So when denominator is going to be maximum, our entire expression or f minimum is going to be minimum. So so that's what I told. For a given angle theta, this is the minimum force we apply. But if given choice that theta can be also changed, then we can do that thing also, no? So the minimum force that we need to apply to make this object to be dragged on a rough horizontal surface is mu mg by root over 1 plus mu square. Now, all of you understood now? Suraj, you have joined now, man. I've repeated it already once. Okay, I'll repeat as fast I can once more for you only. So what we have is we are applying a force F at an angle theta with the horizontal in order to slide this object on a rough surface having coefficient of friction given as mu. So what we did here is we took the components of this force F cos theta, F sin theta along horizontal and along vertical. Okay. Other forces that will come normal contact force mg and the friction force at the verge of slipping, the friction force that will be acting will be maximum. And for us to be able to make this object to be dragged on the surface, the force which is really making this object to move on the horizontal is F cos theta, that you get that. So for us to be able to move this object on the surface, F cos theta should be more than F max. And F max is going to be mu times normal contact force. And this object has got no motion happening in the vertical direction. And we are applying this force F in a manner such that we are not making this object to lose contact or get lifted from the surface. Okay, so normal contact force is not going to be 0. So we'll find whatever it will be. So since there is no acceleration at all in vertical direction, so net force 0, net force in upward direction F sin theta and n must be equal to mg. Solving it, we got normal contact force to be this. Plugging the value here, we got, and for the solving, we got F to be more than or equal to mu mg by all of it. So for a given angle theta, the minimum force that we must apply is this much. But if given choice that, okay, theta can be also changed. So what we see, the minimum force of whatever we got is also a function of theta. And we know that if I have some expression in which when denominator becomes minimum or maximum, we can talk about the entire expression. So numerator is constant, not going to change by changing theta. Denominator, if I make it maximum, this entire expression will get minimum. And we know cos theta, a cos theta plus b sin theta maximum, it can become as root over a square plus b square. So cos theta plus mu sin theta maximum, it can become as root over 1 plus mu square. So the minimum force that we must be applying is this, no? All of you understood?
Yes, sir.
Okay then.
Sir?
So, yes, tell me.
Sir, I have one doubt here, sir.
Tell
Sir,
me.
why
Tell
we
me.
have to consider n to be less than the weight, sir?
It is less than weight, no? I'm not considering it less than weight. It is less than weight because what you see in the vertical direction is the object has got any acceleration, no? So net force
Yes,
should
sir.
be 0. So for net force to be 0, F sine theta plus n should be equal to mg. And for that to happen, n should be equal to mg minus F sine theta, no? Correct? So normal contact force was earlier how much in case if I don't apply any force is mg. Correct? And
Yes, sir.
Here it
friction
is
force
0
in that
means it
case,
is equilibrium, no, sir.
yeah, normal contact for 0, that is something other thing I was talking about. That if you apply a force which is more than mg by sine theta or equal to, then normal contact force will become less than or equal to 0. It means the object has lost contact with the surface.
Okay, sir.
So that
Then
is
it has
something
got
which
projected
yeah
upward.
that has been lifted upward. So that is not something which is going to happen because we are not applying a force bigger than mg sine theta. So it is going to be in contact because if there is no contact, how come we can talk about friction force, which is a contact force? Understood? No?
Okay, sir. Now I
Okay.
understood, sir.
Okay then. The next case we'll see if I am going to push an object, what will happen? So here, because of pulling action, the vertical component is reducing the normal contact force, hence making the maximum friction force to get reduced. No? Okay. I copy this thing, everyone. After copying, tell me.
Can you repeat over that F cos theta is greater than mu n?
Yeah, correct. No. F cos theta should be more than or equal to maximum friction force. And the maximum friction force can become is mu times normal contact force. No? Understood?
Your N is white. Why N is taking place, sir?
Normal contact force, man. What is maximum friction force? Limiting friction. Mu times normal contact force. Last class, remember, no? Got it? Okay. Copy, I'm waiting. After copying, tell me. No,
Sir, I have a doubt here, sir.
please tell me, no? Please tell
Sir,
me.
you have said that f cos f is greater than or equal to nu mj plus by cos theta plus u sin theta.
Yeah,
no,
correct,
sir?
correct.
But if
See,
the
what we
force
have
is
is, wait.
no, sir, if the force is
No.
equal means then the object will be at rest.
Wait. So just to move it, no? I have to say, suppose if I'll give you 3 Newton friction force is maximum friction force. If I apply 3 Newton, then at that point the slipping will start, no? We have to take
Yes,
some
sir.
limiting case. How much more than 3? It can be anything. I have to tell some answer or not. How much minimum I should apply? What answer you will give? 3.1,
Please, sir.
3.01, 3.0001. Anything more than 3 is okay. That's why we give answer as 3, no? Understood, no?
Yes, sir. No, sir,
Got
I
me?
am asking that if the force is equals to friction means then the object will be at rest, na, sir.
It will be having 0 acceleration. So I have to give some limiting answer or not?
Yes, sir.
So maximum friction force can act is 10. If I apply 10, then it will not move. But if I'll say minimum, how much I should apply? 10,
Yes, sir.
just to give
Yes.
some.
Now
Understood? No?
understood. Also.
Okay. Because if I'll ask you how much minimum I should apply, answer should be more than 10. But how much more than 10? 0.10 zeros and 1 it is also okay. 10.01 is
But
also
if
okay.
these two values 10, that's why you are.
Yeah. Understood? No?
Yes, okay. Now understood.
This is the way we talk about things. Copy after copying, tell me. Next, we will see the case of pushing. Now you understand now what it means by taking component. So I have got this force F acting here. So the component which is making this object to move is F cos theta. And the other component, which is F sin theta, you can see that is pushing this block into the ground now. Apart from this, we have normal contact force acting upward. And we have got mg acting down. And again, this block has got tendency to slip forward. Friction force will be acting backward. So what you see in the vertical direction, if I consider it is having no motion, so net force must be 0. So we have normal contact force acting upward must be equal to F sin theta acting down and mg acting down. No? So here you see what exactly this normal contact force is. It is more than mg or not. So what this component F sin theta is end up doing here is it is increasing the normal contact force. Hence, it will end up increasing the maximum or limiting friction. So what we have is maximum friction force that we have got is mu times normal contact force. So for us to be able to drag this block on the surface, the F cos theta must be more than or equal to mu times normal contact force. So we have F cos theta to be more than mu times mg plus F sin theta. We'll simplify this thing. We have F cos theta minus of mu times F sin theta to be more than or equal to mu times mg. So we get F to be more than or equal to mu times mg by cos theta minus of mu sin theta. Now for a given theta, so the minimum that we must apply is mu mg by cos theta minus of mu sin theta, no? Now, what we had was for a given angle theta, the minimum that we were supposed to apply is cos theta plus mu sin theta, correct? And here the minimum I must apply is cos theta minus mu sin theta. So, which is more? In case of pulling case, the F minimum for a given angle theta is mu mg by cos theta plus mu sin theta. Obviously, this is going to be bigger, and it must be because normal contact force is increased. That's why it is always easier to pull than to drag. Sorry, it is easier to pull than to push. Okay, all of you understood now?
Sir, when the minimum force applied on pulling an object equals the minimum force applied on pushing.
Then F cos theta. See, what we have is if this equation is satisfied, this satisfied, this satisfied, this satisfied, no?
Yes, sir.
So if F is more than this, then F cos theta is more than mu times n. Understood, no?
Yes, sir.
Suppose if I had x minus y more than 2, x more than 2 plus y. So if x is more than 2 plus y means x minus y will be more than 2, no? Same thing here.
Okay, sir.
Okay, then copy. After copying, tell me. But even though online, you're able to understand everything, no, properly. It's not like you're not getting it. And difficult questions, the one that I have to take, I'll be taking in offline class. So easy ones, that is straightforward things, that is only I'm trying to take here. Okay. Now we will do 2-block problem. Okay, now. So what we have is suppose one block kept over another block. And once we do this, then we will do 3-block problem. So we have 2 blocks. One is suppose top one M1, below one M2. And both of these two is kept on a smooth horizontal surface. And the surface between our M1 and M2 is rough, and it has got coefficient of friction mu. And what we are doing here is we are applying a force F on M1.
In all case, coefficient of will come, sir.
In between M1 and M2, we have got surface to be rough, and the friction coefficient is mu. But between M2 and ground, it is smooth. Okay. So here we are applying a force F, and we have to find the maximum force F that we can apply so that both the blocks can move together. Do you want me to solve it straight away? But I'll suggest you try drawing the free body diagram. I'll give you 30 seconds for that, and then I will discuss it. Okay, now. So first draw the free body diagram indicating how friction force will act between M1 and M2 when we apply a force F on M1 in order to move M1 and M2 together. Okay.
Force is applied over M2.
M1, top block, upper block.
Sir,
Yes, tell me.
sir, here the force is acting on the block with mass
Um,
m1.
yes, correct. Top block, down on the upper block. Yes.
Sir, I have one doubt.
To buy.
Sir,
Yes, tell
here
me.
there's a rough surface means then the friction will act between M1
Friction
and
is there.
M2, not sir. So if we move the
Yes,
block
obviously.
if we move the block M1 with force means then M2 also will move, na, sir.
Yeah, correct. That is the whole thing is all about. Yes.
Okay, sir.
It's not a doubt. It's we are understanding it. It's not a
Yes,
doubt.
sir.
We're getting it correctly. And to buy this Google Meet the subscription, the one which has recording facility, I have to buy a domain. Then I made a fake website, just a dummy website. Then only they allowed me to have this subscription. So, but it is quality better a little bit, the audio quality, video quality, no, than free version.
Yes, sir. I checked that video, sir. It was nice.
So like that, whenever we'll have an extra class, we'll share this recording also. Okay. In future, we'll not have extra classes as mostly. Just I'll have for discussing some high quality questions. Nothing much. Not for teaching anything new. I also hate taking online. It's like very boring. I can't see the students. No, it becomes very boring. Okay, so I'll draw the free body diagram now. Now, what do you do to draw the free body diagram? Suppose if you consider if there was no friction, then how the surfaces will slip over one another, that you have to see. So if there's no friction, then M1 will be moving rightwards, no? Or maybe I'll say if no friction, the M1 will have a slipping tendency towards right side, no? So the friction force always comes in a manner to oppose the relative motion. So friction force on M1 will come backward. So, and the moment you know the friction force on one of them, automatically the reaction of it will be on the other one. We can come to that. Automatically, we can tell how the friction force is going to act on our other block. The friction force on M2 will be acting forward. Or what we can do, we can find how which way the friction force is going to be acting on M2. Then we can find for M1 by action reaction pair. So you see that M2 is having a tendency to remain there only. So we can say that the reason why relative motion is happening because M1 is leading, no, and M2 is lagging. Correct. And I want to make M1 and M2 not to move away from each other. Then what I must do? I must slow down the one that is moving faster, and I must speed up the one that is moving slower, or not. I want to catch up one guy with the other one. So I may make the faster guy to go slower, and I may make the slower guy to move faster. Something like that we can think of. So even I can say the surface of M1 is the leading surface. In that manner, we have talked about also no leading and lagging. And the surface of M2 is the lagging surface, no? So if there is some arrangement by which if I can make M2 to always moving along with M1, then there will be no slipping. So what I must do? I must, and since M1 is moving towards leftward direction, so I must apply some force on M2 so that M2 must move towards leftward direction. So on M2, and what force can come? It's not like any other force can come other than friction force. So the friction force that will act on M2 must be in this direction. All of you get that? Or even without all of this, still we can come to the way friction force will be acting on each one of them. If I see that why, if I'll ask question that why M1 is moving, so you can say we are applying force F, so M1 moves. But why M2 will move in this direction? Tell me. There must be some force on M2. So what force can come on M2? It's not like God will come and help M2. So from what friction force will come? Friction force only will come. So for M2 to be able to be moved in that direction, the friction force must come forward. Automatically, once we know what friction force is in M2, we'll know what force will be acting on M1, which will be backward, no? Correct. So all of you got the free body diagram correctly the way I have drawn.
Doubt, sir.
Please tell me, Ashwin.
You said that M1 is moving towards the left direction, but M2 is how moving in the right direction.
That's what. Now see why slipping is happening. I can say glass half full and half empty. Same thing or not? Same way, I'll say why M1 and M2 are not moving together because M2 will be lying there only and M1 will move ahead. So if I will stop M1 from moving, see, the purpose of friction is not to stop the object. That we must be clear about it. Purpose of the friction is to stop the relative motion. So I can have relative motion gone if both the objects are stopped, or I can have relative motion stopped if both the objects are moving together also or not. Understanding that point. So here M1 is moving over M2, that's why their surfaces are having some relative motion. But if at all M2 also moves along with M1 with same velocity and everything same, then there will be no relative motion, then there will be no slipping. And M1 can't be stopped, so I can make M2 to be dragged further along with M1, always with the same velocity, doing everything same. Understood? No. So we are trying to make prevent relative motion. We're not trying to prevent motion, no. Okay then. Now, so what we do is first I consider that okay, both of them since they are moving together, they must be
Sir?
having same acceleration. You tell me.
Sir, also the M1 or M2 wants to go in the direction, then the mass of the M1 should be greater than mass of the M2, na sir?
Why? How mass
Sir,
came here in all this argument? Tell me.
sir, no, sir. If the mass of the M1 is greater, then the friction between them will be more, na sir?
Okay, that we will see. So in that manner you're talking about, that we will see. That is what we're trying to see. Let's check out. You will understand more. So what we have is M1 is going to be having same acceleration, suppose A, and M2 is also going to be having acceleration A. So if I write the force equations for M1 and M2, so what you see the net force acting on M1 in the leftward direction is F minus. Now before that, why I have taken the friction force to be unknown here as small f? Because M1 and M2, I am considering they are moving together. So if they move together means no slipping. No slipping means what kind of friction force will come? Static friction. And static friction is not, doesn't have a fixed value, no? It will be lying between 0 and the maximum possible value of the friction, which is mu times normal contact force. We don't know how much it will be, just we know the range of it, no? That's why we are assuming it to be small f. Okay. So net force on M1 is going to be capital F minus small f, that will be equal to M1 times A. Net force on M2 is just F, so that will be equal to M2 times A. So this is equation number 1, this is equation number 2. Suppose if I add this two, what you get is small f gone. So capital F equals to M1 plus M2 into A. So the acceleration with which both of them will be moving together will be F by M1 plus M2. And we can come to this conclusion about acceleration directly also. How? That sort of thing we have done also. You remember that 3-block system connected by strings. Remember, no? Tension force became internal force if once I took all of them as one system. So same thing if I'll do here. If I'll take both of these two as a single system, and since both of them are moving together, So both of them will have same acceleration. So whenever system in every part, whenever we have every particle in a system moving together, in that case, what we can do? I can write down in general as net force is going to be net external force plus net internal force acting on a system. And net internal force is 0 only. So net external force is going to be just F, the one that is acting on M1. And that should be equal to total mass into A. Total mass of the system is M1 plus M2 into A. So from this we can say, we can come to the same conclusion. Have you understood this extra thing? Even without knowing it now, you can solve the question, but all of you understood now? Okay, then next coming to the friction part. Now see, then what do? You look for the object whose motion is only going to be decided by friction force, because M1 has got forces acting on it, is the friction force and the applied force F both. Correct? But M2 has got only force acting on it, which is the friction force. So the motion of M2 is decided only by the friction force or not? Understanding that point? So the motion of M2 decided only by the friction force. So you look for that object first. Just a moment, let me make some space here. First, we will see what is the maximum friction force that can act between M1 and M2. So M1 normal contact force upward, and we have got M1G acting down, capital F this way, friction force this way. So normal contact force is going to be M1G. So the maximum friction force that is going to come is going to be mu times M1G. So in between whichever surfaces we are finding friction, we must consider the normal contact force acting on that surface only, no? Now next, M2, only force that we have got acting on M2 is F, friction force, small f, no? Now, what is the friction force will be if I consider the acceleration that we have got here. So friction force is going to be M2 times A, because this M2 is moving with A. Only force acting on on it is friction force. So we can find friction force which will be M2 into A. So but what it will be? It is the friction force that I require so that M2 can move with A. Understanding the point? Suppose I want to make M2 of some kg, it is to be moved with, suppose M2 is 10 kg, I want M2 to move with 2 meters per second square. So how much friction force should be acting on M2? The one which is making it to move with the acceleration 2 meters per second square will be 10 into 2. So what it is? It is the requirement I have from friction force, or it is the demand we are having. But maximum it can supply is this only, no? Understanding this point or not? So we want the friction force to apply how much? M2 into A. And how much it can supply maximum is mu times M1 into G. So suppose if friction force can give you 25 newtons max and you are asking to give 20, then it is okay. Correct? No? But if friction force is going to give you 15 only maximum, and if you demand for 20, then it can't provide. Then if it can't provide means what? Means M2 will not be able to move with the acceleration with which it must move so that both the blocks can move together. Understanding it? So it means the objects M1 and M2 will not move together, will slip over one another. Understood, no? So what we have is the condition for both of them to move together, that whatever we need friction force to act, that much it should be able to supply. So friction force that we want it to have, it must be more than maximum it can give. So M2 times A must be more than mu times M1G. So A must be more than mu times M1G by M2. So the acceleration, just a moment. Sorry, I wrote wrong. So for us to be able to the max demand should be less than the supply, no? So if I want friction force to be 20, but it can be 15 only, then slipping will happen. So it means friction force maximum must be more than our small f, and the maximum it can be mu times m1g, that must be more than m2 times a. So a must be less than or equal to mu times m1 by m2 into g. So what we have here is the acceleration is going to be less than or equal to this for both of them to be able to move together. So the maximum the acceleration that they must have moving together is this. Now we know F is equals to m1 times m2 into a. So from that we can find F max, which is going to be m1 plus m2 into a. So it's going to become mu times m1 plus m2 into m1 by g by m2. I'll figure it now. Easy only. This part all of you got it. Aswin, this part got it, no? Parmeshwar, this part got it, no? Okay. Okay, just I'll take a new page, I'll give you homework, and then we will end the class. I'm not going to keep class very lengthy that you will not be able to follow much. Okay, I'll
Sir,
take a
1
new
minute,
page.
sir. I will write the last part alone, sir.
Okay, no problem, right? Just I'll write the homework here. Nothing different, same question only. Same question, the force is applied on the lower block. Okay. This surface is smooth. Here coefficient of friction mu. Find the maximum value of F so that both the blocks can move together. Okay. Few more questions. S.C. Verma, page number, I'll tell you, or maybe I'll paste the question, that is also better.
Sir, for the upcoming exam, we would be having full friction lesson or